It is given that a metal string is fixed between rigid support. It is initially at negligible tension. Its Young's modulus is y, density is rho, and coefficient of linear expansion is alpha. It is now cooled through a temperature T. Transverse wave will move along it with a speed. So basically our aim is to find out what about the velocity of transverse wave. So we know the equation for velocity of transverse wave is T divided by mu, where T is tension developed inside the string and mu is its linear mass density. So initially we are using a string, and the length of the string was equal to the distance between the rigid support, so that tension in the string was 0. Now if you are increasing the temperature due to compression, tension will develop inside. So we can find out what about the value of force or tension developed from the equation of Young's modulus, that is stress by strain, that is F by A delta L into L. So the value of force we can find out by using this equation, YA delta L by L. So the value of force or tension is equal to YA delta L, we can take it as initial length into alpha into delta T. Change in length is equal to initial length into alpha into delta T by L. So I'll get the value of F is equal to YA alpha delta T. So if you are putting this equation on the equation for velocity, you can write V is equal to under root of, instead of T we can take it as YA alpha delta T divided by mu. In question it is not given in terms of linear mass density, but it is given in terms of volume density. We know that volume density rho is mass divided by volume, that is mass divided by volume. We can take it as area into length, and this mass by length is linear mass density, so we can take it as this mu by A. So we can write V is equal to under root of Y alpha delta T divided by mu by A. Now instead of mu by A, we can write it as nothing but the value of density. So you can write the value of V is equal to under root of Y alpha delta T, which is given as nothing but T in the question, divided by mu by A is equal to its volume density rho. So this will be the equation for velocity.